Hello and welcome. Today, I hope to be able to convince you to check your secrets into Git. I'm Warren Parad, and I'm the CTO at Authorus, which is a user authorization API and also features user identity, granular access control, and API key management. Before this, I worked at a number of companies building distributed platforms with a focus on security. One of the major themes that came up frequently in my experience was credential management. So let's talk about that. When I say credentials, I mean passwords, API keys, secrets, anything that your production application would use to authenticate and authorize to a third-party service provider. Examples could be your cloud provider, such as AWS or GCP, or a payments processor like Stripe. I don't think it's a stretch of the imagination to suggest that you should keep these credentials a secret and that they should be as secure as possible and try to prevent them from being exposed to a malicious third-party attacker. If you're lucky and that does happen, maybe you'll just have some instances running in your cloud account with crypto miners on them. So what I want to talk through are standard strategies for credential management and review them and hopefully find opportunities for improvement. If you've ever had to do any sort of integration with a third-party service provider, you're probably used to having to go to their UI and copy out the credentials. It may look something like this. This is an example from GCP's OAuth client credential configuration screen. That's a mouthful. The client secret you can see in the bottom right-hand corner is what you would copy out and use. So how does this even look like? Well, you have some service provider that you want to authenticate with. It has some sort of UI that you can go to, log in, maybe click some buttons, and a credential pops up on your screen. From there, you pull the credential out, and maybe you put it in a configuration file, and use Git in your CI/CD pipeline, your deployment pipeline, to get that to production. From there, you have the credential, and you can use it to authenticate back to the service provider, and we're done. However, each of these places that we have, each of these components, is another opportunity for credential exposure. Our credentials are actually exposed here, which means if there's a vulnerability, there's a potential problem. Every additional component we add to our infrastructure, to our pipeline, is another place where a malicious attacker could potentially expose our credentials. So let's review that strategy I just had up and see if we can spot all of them. So at the beginning, your credential provider generated the credentials and had them on the screen. In your browser, well, the browser could be malicious. Did you download it from the official location? Did you make sure that the hash of the binary running on your machine matches what they suggested? How many have done that? Not a lot. Taking it further, you probably have extensions installed in your browser. How many use extensions? How many have checked the permissions and the access and the source code of those extensions to make sure that they're not malicious in nature? Since the credential is being displayed on our screen, that extensions that you have may have access to that credential and then could expose them to a third-party attacker. From there, it doesn't get much better. You go and copy out the credentials, and there could be a service waiting in line on your machine that is just watching your clipboard every single moment, just in case you happen to copy something that it likes. You copy those credentials out, and it exports them to the attacker. Now, it may seem a little far-fetched to suggest this could happen, but at a major password manager, just recently, this actually did. Some vulnerable software running on an operation engineer's computer exported it to a malicious attacker. So there are lots of vulnerabilities here. Well, you take those credentials, you pull them out, and you still need to get them to production somehow. So likely you open up your IDE. Same as your browser. Where did you get it from? Now, hopefully you're using VS Code or an IntelliJ and not something like Eclipse. But even if you are, that too could have a problem. And there's still further. When you are using any language of your choice, I bet you got a recommendation. Hey, Here's a language pack you can just install and everything will work correctly for your language of choice. Did you review those actual extensions that you pulled in there? I know I didn't review every single one of them. But maybe you had a really difficult problem. And from there, you maybe just installed some suspicious extension that only had 5,000 installations. So there are vulnerabilities here as well. And then you have to get them to production still, so maybe we use Git, and we push them to a Git server. Well, the Git server is run by engineers at a different company, likely, right? You're using some sort of SaaS provider, maybe GitHub or GitLab, which means that the engineers at that company have access to your credentials in some way. Now, maybe you're hoping that they have a process in place to limit the number of people that actually have access to those credentials in your source code, but I don't really want to risk the future of my company and the security of the applications and the critical data on a process of one of these companies. And it doesn't get better from there. We have some sort of pipeline to get our source code and credentials to production. You're using maybe Terraform or Pulumi if you're lucky, and maybe a bunch of other SaaS providers, maybe something for code quality as well. Well, every single one of those is another place where your credentials could be exposed. And lastly, we finally get to production. And then we're safe, right? Credentials in production, no problems. I hear some snickers in the audience. Yeah, that's right. There are still problems here as well. The vulnerabilities you could have in your production application, the dependencies and the libraries that you're using, are an additional source. I don't think anyone's reviewed every single source line of code and every dependency and their dependencies and their dependencies just to make sure there's nothing there. And even so, there could be a 0-day undiscovered vulnerability just waiting there until your credentials get to production. You've deployed your code somewhere to a cloud provider, hopefully, or an on-prem solution. The operations engineers also have access. And I know that we care about the reliability of our software, right? So we're probably logging every request and response that comes in and out of our service. Well, that too is going to contain their credentials. Remember, we're passing the credentials to a third-party service provider. And someone with access to those logs, even though they don't have access to production or the source code, would have access to that exposed credential. Now, that's a lot of places, right? Let's just have a quick recap. The browser, not a great start. And your system, 2 giant places of vulnerabilities. Further, you're using some sort of IDE, and maybe the credentials are in plain text. And you had to use a Git server and use a CI/CD pipeline to get those to production. All of these are sources of exposure. Because you're using some shared services, I bet other engineers have access to those same services on your team. So we have to include them in the picture. And the last part is the infrastructure that you're using and the logs. Now, I'm sure some of you are thinking, come on, Warren, like no one uses plain text to store their credentials. That's ridiculous. And I say that, but I've seen it in the wild. I'm going to pretend I don't because I really don't like seeing that, and I move on. But the next step is probably using environment variables. Environment variables are a great way to dynamically inject configuration into your production environment. So what I want to do is review the strategies that we have and potentially see what we can do. So environment variables are really the first step that I think a lot of companies, a lot of technology teams take. And most languages and frameworks, I really wanted to say all, but I was really hesitant during my preparations to commit to that. And here's some examples from C#, JavaScript, and Rust of how you may actually do this. This is only part of the solution, though. Environment variables just do the resolution and injection into your production application. You need somewhere to actually store the credentials. If you're using a third-party Git solution, then they likely provide some sort of secrets management. Here's an example from GitHub, which is their repository secrets. You can come here and enter a secret, and then maybe it's available for production later. There's some interface, you can track what's happening to it. So let's flash back to our original flow where we used the configuration file. And instead of passing the credentials along, we'll stick in the Git secrets manager, Git server secrets here, and we can see we can inject it in. So it's a little bit of a change. Now, if you've ever done this before, you probably realize that you can't just do this and have it work. And that's because there's no connection between the storing of the secrets in a Git server, GitHub, etc., and actually utilizing them in production. We need to introduce a new component here, so an additional place of exposure. And that's the application control plane. It's a place where we can actually resolve those environment variables and inject them in directly. So we made a change. Let's take a look back at how this affects our list of vulnerable locations. Well, we didn't really change how we pull the credentials out. So the browser and our systems are still in play. We did make a small change to how we're storing them. So instead of ID in plain text, now we have the Git secret server. We just made a change one for one here. So as far as a list of exposure locations go, we didn't really change anything. The Git server itself and your CI/CD pipeline, if you're using Terraform or Pulumi, are just further places that didn't really change. We still need to get those credentials to production. And because we're using a shared system, other engineers on your team also still have access. We're still using them the same way, so the logs in your infrastructure don't change. However, because we introduced the environment variables and we needed to add the application control plane to actually interact with them, we have to throw in an additional exposure location here. So if we look back over this list, when we're using environment variables, we can actually see not only did we not improve, we actually made it worse. Using environment variables is a mistake for credentials management. I don't know if that's the conclusion everyone was waiting for, but it's net negative overall. So we really have to do better. And luckily we can. There exists a thing called a secrets manager. Most of the cloud providers offer it, and additionally, there are SaaS versions and open source to help us if we don't want to use it or are using a cloud provider that doesn't support even this minimum level of security. What does this look like? Well, it's very similar to how Git server secrets work in GitHub. You have some interface, there's an input box you stick your credentials in, and maybe it tracks who edits them, how often they're used, etc. How it actually works is there's some interface. You push your credentials into Secrets Manager, and it stores them in a secrets database. Then later, when you want to pull the secrets back out, you call the available interface or API to do that. Okay, let's use Secret Manager. How does that change things? Here's our original flow using Git server secrets. And now we'll switch out and put in the Secrets Manager. And you'll see we actually can switch where we're injecting them into our pipeline. We can completely eliminate the Git server as part of this. We're still using the CI/CD pipeline and the rest of the flow because we're using environment variables. Now, if you think about this for a second, you may notice that you don't have to use the credentials outside of production. And as a matter of fact, they shouldn't be there. They shouldn't be visible outside of production anywhere. In this flow, they're visible to your IAC deployment pipeline. The credentials are a production application requirement. Exposing them outside of that doesn't really make sense. So we can actually use Secrets Manager to avoid this problem as well and directly inject them into the application control plane. Depending on the cloud provider you're using, there may be some sort of first-class integration here. As long as we're using the environment variables, though, we have to deal with this unruly, unsightly object, this component that increased the source of exposure of our credentials. Well, if we just want to get rid of it, we just have to stop using environment variables. So let's do that. This is our flow where we're using an environment variable. Luckily, Secrets Manager supports an interface, an API that you could directly call with production. So let's do it. Let's directly call Secrets Manager with the production application at runtime, and we don't have to worry about unnecessary extra exposure. And just like that, because we eliminated environment variables, we improved the security. So how does that change things? The browser and our system, unfortunately, are still in play, right? We haven't changed how we're generating them and how we get them out. Our CI/CD pipeline, though, is no longer part of the picture. That's a plus, improvement, finally. But we're using a shared system, so other engineers on our teams will still have access to those same tools. If they have a vulnerability on their machine and they go to access the credentials, then it will be exposed. And we haven't changed how the credentials are being used in production or what has access to them there, so they could still show up in our logs, and anyone with access to the infrastructure may still be able to resolve them. Unfortunately, we've added an additional component, the secrets manager, and it has an interface. Well, the engineers on your team, like I said before, but also the cloud provider that you're using that runs the secrets manager could still further have access there. And lastly, there's a secrets database, a database with all your secrets in it. I don't want that to be exposed, but it's sitting there, and if it does, then a malicious attacker can come and impersonate your application and get access to your critical infrastructure. Overall, it looks like a little bit of an improvement. And if you stop here, you did the minimum job. We actually improved over the original flow and much more over environment variables. So if you've gone this far, you can give yourself a pat on the back. I'm not comfortable stopping here, though. There's lots of opportunity, especially on the engineering side, to improve and reduce the exposure locations. Luckily, cloud providers usually offer some sort of service known as a key management service. This uses encryption instead of a database to manage credentials. I'm going to walk through how it works right now. You get your credential from the service provider, and you pass it to the key management service. Key management service encrypts it and returns you some encrypted credential back. It doesn't store the credential anywhere. It discards it from memory, which means we have to do something with it. And so this is where we're going to take it and commit it to Git. I know that's what everyone was waiting for me to say. Once it's in Git, we'll deploy the encrypted credential to production, where we'll execute the reverse flow. We'll get the credential, it's deployed with our source code, and we'll pass it back to the key management service. From there, it will decrypt it and return us back the decrypted version for us to use as we please. So, instead of secrets manager, let's try using the key management service. As before, we have the service provider API. It generates the credential for us and makes it available in the UI, where we can go and copy it out. From there, we pass it to the key management service and encrypt it and get back the encrypted version. Then we commit it to Git, use our CI/CD pipeline to deploy it to production. From there, we just do the reverse. We take the encrypted version, send it to the key management service, and get back the decrypted version. Once we have it, we can authenticate to the service provider, and we're done. So, with that, let's review how the key management service actually does here. Well, the browser and the engineering system are still here. I really wish we could do something about that, just not with the key management service. The deployment pipeline, untouched. What we improved with Secrets Manager, still improved with the key management service. So, benefit. We're still using a shared service, so other engineers on our team will have access. But there's a caveat here. In order to get access to the credentials, you need both access to the source code and access to the interface for the key management service. Both those pieces together are required. So it's way more secure than storing it in a database. And because we're resolving the credentials at runtime instead, we don't usually have to worry about the application infrastructure. We can decrypt the credentials when we want and potentially throw them away when we're done. But it can still end up in our logs. Because we have no database, we don't have to worry about it being exposed. So everyone should be jumping for joy there. No one's jumping for joy. Let me try that again. Anyway, so there's a couple other benefits here as well. Because we're using source code to store our credentials, we can use all the same auditing tools, all the IDEs that you've got, whatever you're using today to manage these credentials. We don't have to introduce any additional systems. And lastly, I hope no one has to do this, but when you have to rotate credentials, using Git makes it so much easier than trying to figure out some complex process to make sure what ends up in production is exactly what needs to be there. Changing source code changes what's available. So I said a lot so far. Let's have a quick review. Environment variables are literally the worst. At no point should you have credentials anywhere near your environment variables. They just don't work. They're not secure. We've seen that. Further, secrets manager is okay. It's the minimum job you can do, but it does improve the security of our applications overall. So feel free to take that step. But most importantly, we should encrypt the secrets using a key management service and commit them to Git. That's the best we can actually do. Can't do any better than that. And the reason we can't is because we don't really control what the service provider is giving us. They're giving us a random string of characters, potentially, that we just have to store and give back to them later. And as long as we don't control that, that's the best we can do. I'm going to stop here for one quick second. Let you take that in. Now, at some point, you'll probably be the service provider. I know no one's looking forward to that. You have users, technical ones, that want to integrate with your APIs. So you need to generate credentials for them. So I don't think it's a full picture to just talk about the client-side issues. We should talk about also the service provider side ones and join them together and get that full, complete picture. So let's do that. How does credential generation work? Well, your application is now a service provider. So you have some sort of credential generation function, and the result of which is some credential you'll pass back to your user once they've logged in. In order to verify that credential later, you're going to have to store it in a database. There are problems with this flow. Maybe some people already see that. The service provider, your application, has a standard set of vulnerabilities that we talked about before. The libraries that you're using in production could expose this. Engineers have access to the source code. There's lots of ways to potentially tamper with this and expose those credentials, intentionally or unintentionally. Your credential generation function could be an issue. If you're just using a random number generator or generating a random string of characters, then it could be vulnerable in some way. At the very least, it should be a UUID or a secure random generated credential. But that may not be sufficient. And lastly, the database. We're storing a whole list of these credentials in the database for our users to do the comparison. So if our database leaks, the credentials in that database are available to a malicious attacker to use and impersonate our users. And detection engineering is a very hard thing to do correctly. Knowing that our database leaked is a problem. And it gets worse from here, actually. We return those credentials back to our UI to make them available for anyone that would use them, the engineers that log in. Well, the UI itself could be susceptible to cross-site scripting attacks. One of your users could get phished, end up on your UI that's vulnerable, and if the credentials are displayed there, then they could be exfiltrated to a malicious third-party attacker. That's just one of the list of vulnerabilities that a UI has. If you're logging on the client side, like you might be, similar as the server side, well, then the credentials also show up there. The logs could be accessible to different people, exposure of your credential. And lastly, I know how much we care about the user experience of our users. So we're probably recording every last thing that they're doing, like every button click, every thing they see on the screen. But if you're recording what they see on the screen, that's going to include the credentials as well, which means that if you're exporting these analytics to a third-party service provider, you've exfiltrated your user's credentials yourself. I mean, maybe you can look at it as a backup database in case I won't go there. Okay, and we know what comes next, right? Because we just talked about it. The service provider credential gets to you, and you encrypt it with the key management service, and you pass it to your production application. And from there, you decrypt it and send it to the service provider back again. Unfortunately, there's more vulnerabilities. Well, the credential comes in with your request. So if you're logging the request or your service provider is logging the request, then the credential's there as well. And the same thing will go if you've got any sort of APM, analytics, etc. Even if you're putting it in a header, which is a better improvement than a query parameter or a body parameter, it could still be exposed, especially if you have some sort of aggregates. So let's look at the full picture now that we've got it, including the service provider vulnerabilities. Well, here are the three from before: the engineering system, our production runtime, and other engineers on our team. Remember, we're using a key management service, so that's a shared infrastructure. And pulling in the ones that we just talked about from the service provider side, we have the service provider database where the credential is stored, our browser, and the service provider UI. I've coupled those together because I think if we solve one of them, both of them will get resolved. And the last one is the logs and the infrastructure that they have. That's another long list, but I think we can get through it. There's a lot of things that we could potentially do here, and I'm going to suggest that while we could take any one of those paths, the one that's going to give us the most value and be the easiest to execute is by revising the credential strategy, how we're actually generating the credentials and how we're verifying them. What I said before is you've stuck the credentials in your database so that on an incoming request, you can look at the API key or whatever is there, bearer token, and compare that to what you've saved. You may even have some code that looks like this. However, if you have this code in your production application right now, you actually have a vulnerability. Doing a standard comparison like this is vulnerable to what's known as a timing attack. It's a more intelligent brute force strategy that an attacker could use to discover the credentials. You'll actually tell them with your API. I'm not going to get into a lot of details about how to execute this, but to defend against it, we just have to use a timing safe equals function. They usually exist in most languages. So if you have an API and you're managing credentials and you're not using this, you have a vulnerability today already. Although it doesn't just stop there. We know that storing the credentials in the database is problematic. And so the next step on top of this is to salt and hash them and do the comparison based on the hash. We do this with user passwords all the time. I hope we are anyway. Using bcrypt with some salt and some hash, some repetition. I mean, if you're not sure what I'm saying right now, I think it's a good, clear identifier that doing this is actually pretty difficult and getting it right. So talking about not getting it right, I'm going to flash back to a slide earlier where I showed GCP's OAuth to credential configuration screen. We can actually see the credential here in the bottom right-hand corner. But every time I come to this UI and refresh the screen, the credential is still there. If one of my team members goes to the screen and they look at it, the credential is still there. It's there every time. That means that Google persisted this credential in their database. And we know if they have it in their database, it can get leaked. So what you really want to look for is one of those warnings that says, hey, you have to copy this credential out because we're not going to display it a second time. And while they could just put that warning there and still return the credential anyway and be doing other suspicious things, we can hope that maybe they've thought about it slightly more than the engineers behind this screen did. So how do we get around this? Well, if we're generating the credentials, rather than trying to get this all right, even when giant platforms can get this wrong, let's use asymmetric key cryptography. I don't hear anyone jumping up and down. And I know cryptography is a scary word, but I'm going to get you through this. There are lots of libraries out there in most languages. Some actually don't have it. It is difficult to generate credentials correctly in some languages. The language you use could make your application less secure. That's an interesting thought. Back to public and private key, asymmetric key cryptography. So, how does this work? Instead of the credential generation function we had before, we'll generate a public key, and we'll return the private key as the credential to be used by your production application or your user. Instead of passing that back to the service provider, we'll use it to sign a JWT or a JOT, and we'll use that as the credential we send to the service provider, and they'll verify it using the public key. Okay, so how do we throw this in our flow? How do we update this now that we have this new technology at our disposal? When we generate the public key at the service provider and we store it in the database, it's fine to do that. It doesn't matter if it leaks, everyone can see it, it doesn't matter. We return the private key to the service provider UI where you can copy it out. And then we know how this works. Use a key management service to encrypt the credential and deploy it to production where you decrypt it, sign the JWT, and pass it back to the service provider. Awesome. So this must have changed something. Let's hope it changed something. A lot of effort. Maybe it's worth something after all. Well, unfortunately, the engineer system, your production runtime, and other engineers on your team are totally unaffected, right? We're still using a key management service, shared infrastructure where the secret is being stored, so it's unaffected. Well, that sucks. However, because we're not storing the credential in our database anymore, it doesn't matter if our database leaks. As a matter of fact, your whole database can leak. It can be available on the internet for anyone to use or look at all that data, and no one will ever be able to impersonate your users at all. Now, they may have some other problems if you plaster data all over the internet, but user impersonation is not one of them. And unfortunately, that's the only benefit. Our browser is still in play along with the service provider UI, and the credential is still visible on the service provider when they generate it. Now, if I flash back really quick to the previous slide, we may have noticed that the private key credential is visible in two places, between the service provider API as it's passed to the UI and to your browser when you go and copy it out. These are both places of vulnerability. The credential's exposed here, and if there's an issue, well, then your credential can be exposed, and a malicious attacker will get it assuredly and do something. But we know that the credential is the private key part of the pair is discarded from the service provider after it's generated. So what if we change where we're generating the pair? Instead of on the service provider API side, what if we shift it to your UI and then upload the public key back to the service provider? Now, I'm sure some of you are thinking, that's ridiculous. We can't have key generation in our UI. That doesn't make any sense. But if we look at the list of vulnerabilities, the list of exposure locations, and this diagram, we can see that it's a clear improvement, that we've actually eliminated one place. And you could stop there if you want, but I'm going to suggest to go even further. Push the generation back to your engineers or to your customers' engineers to generate the public and private key. Then upload the public key to the UI, which gets to the service. This is actually known as bring your own keys. And so if you're integrating with a third-party service provider, it's a good reminder that if they offer that option, they definitely thought about security. The rest of the flow, though, is exactly the same. We encrypt the credential with a key management service and pass it to production, where it decrypts it and signs the JWT to be authenticated with the service provider. So let's see how we did. That's unfortunate. Engineering system, production runtime, other engineers, well, we're still using key management service, so no change there. But with this one simple trick, we've eliminated the service provider completely. So if you are the service provider and you provide bring your own keys, then you are almost completely off the hook as far as the vulnerability in this area goes. You don't have to worry about an issue in this way. But I think we should go further. Call me ridiculous, I guess. And eliminate the engineering system from the picture. We know that the browser, your IDE, whatever tools you're using are a huge source of vulnerabilities. As long as you have to generate the credentials on your machine, or your users have to generate the credentials, they could be prone to attack or misunderstanding even, right? Don't attribute to malice what can easily be ascribed to negligence. So let's push it all the way to production. We have a production application and the service provider. What if we generate the credentials at runtime? Generate the private key and the public key and upload the public key. Now, you'll need to implement some way of exposing the public key in your production application, maybe an endpoint, or it writes it out to some log file, and then you'll upload it like you did before in the bring your own keys scenario. Later, when you actually want to authenticate, you can sign the JWT with the stored private key and pass that to the service provider. The service provider compares it with the stored public key, and we've eliminated potential malicious attackers from this picture. Okay, so with the public key improvement on this strategy, let's see how this changes things. That should be an opportunity for celebration. It's no longer an option where you're not using your system anymore. Production runtime is still in the play, but other engineers also won't have access. We're not using a key management service here potentially. So there's nothing to be shared. Production is generating the credential and handling it all itself. You'll need to work with your service provider to actually offer this, but if this is you, this seems fantastic. And we didn't change how the service provider side works, so at this point, it's still out. And just like that, we eliminated pretty much everywhere. So we're done. Well, there is this just one last place remaining. And while you don't have to go further, those of us that are adventurous, I recommend you looking into hardware security modules, or an HSM. An HSM is a black box private key that does a lot of what we've already walked through. It handles a lot of that on-chip, on-board, so you don't have to worry about that complexity. You don't have to worry about getting cryptography wrong. You just implement the interfaces that are there, and we go along. Here's an example of a TPM on board, which is sort of like an HSM. I'm sure someone will call me out that these aren't the same thing. And on the right-hand side is a YubiKey, which hopefully we're all familiar with in some form or fashion, which is usually used for user authentication for WebAuthn, FIDO2, improved. But we can use it in production as well. And how we actually use it is very similar to the previous case, except we just throw the HSM into production. We utilize it. And the way we do that is the HSM is the one that generates the public key and passes it to production. From there, it uploads it to the service provider. So that's not that much different. Later, when we want to actually generate a JWT, we issue a challenge to the HSM, and we get back a signed JWT, which can be passed directly to the service provider, where it can authenticate and prove that your production application is really who it says it is. That was a lot to walk through. So let's have a recap here. What have we learned? I think everyone knows what comes first. Environment variables actually create new attack vectors. They make our application and the security of our applications worse. So we really need to avoid them at all costs. Additionally, the best we can do is use a key management service and encrypt our credentials and commit them to Git. Doing anything else is not going to measure up to this. And it's the best we can do as long as we don't control the credential generation. As long as we only control the client side, how we manage the credentials, this is the best. And lastly, if you are the service provider, you should think about bring your own keys. The asymmetric cryptography with public and private key pairs is the most secure interaction that we can have here. It helps your clients, your users, eliminate a whole class of potential vulnerabilities. If that isn't a good enough justification, you don't have to worry about vulnerabilities on your side. I'm sure all your CISOs would like to hear that. I think most importantly I'm going to say, and given the number of things that have been in this presentation, I know it's a lot, that API security takes a lot to implement. It's not just a 20-minute adventure. Don't expect that one ticket in a 1 to 2 week sprint is sufficient for getting security up on the client side or on in your production if you have a technical API. I think it's a good reminder that security is just hard. And with that, I have a quick link to this presentation, but thank you for coming. I'm Warren Parad, the CTO at Authorus. Okay, and now we have plenty of time for questions, so ask your heart out. Okay, here we go, up here. I think you need to wait for the mic runner 1 second, though.
It's a very simple question. Can you put again the QR code for your slides? Because you
Yeah.
so fast that I...
Yeah, sorry. You want this.
Okay.
Is it too big?
Perfect, thank you.
Okay.
Hello. Great talk, by the way.
Thank you.
In the key store and in the key manager scenario, what about the key manager secrets? Where do you store those?
Yeah, so how about the secrets of the key manager? So I glossed over a detail here, which is that the key management service does store one important piece of information, and that's encryption of the key, the credential that you're passing in. How do you actually do encryption? Well, you need a private key to do that. And so it could leak that private key. So what do you do? Well, you know, it's interesting you asked this. I actually had a slide in the presentation before, so I'm going to actually quickly run through the answer to that question, which I have. It's called using a data key. So instead of having the credential, what you do and passing it to the key management service, you actually generate a data key on your side and use that to encrypt the credential instead of the key management service. Then you use the key management service to encrypt the data key instead, and you take both pieces of information and you commit them and store them to Git. From there, the rest of the flow is the same, except you decrypt the data key, which you use to decrypt the actual credential. This creates an extra level of abstraction. I'm going to quickly go back through this other slide just so you can see it. So encrypted key, encrypted data key, both pieces of encryption to Git. What this does is it prevents the exposure of the key management service because the data you're passing to the key management service is no longer your credential, it's this data key, which now means instead of 2 pieces of information, you need 3. You need access to the key management service to decrypt the data key. But your credential never gets to the key management service at all. Like, it never gets there. You don't send it. You're doing it all on process on your side. So an attacker that gets access to the key management service may have access to the data key, but unless they know for what application that's running, it's impossible to resolve the credential. And so this is an extra complexity on top of the key management service, but if you are worried about those higher security problems, I definitely recommend introducing it. Does that answer your question?
Yeah, thank you.
We got 2 here.
Hello, congrats for the talk. It's really good. I have 2 questions.
Okay.
First one is how does Git fit with the ultimate recommendation of generating your own key on production directly and storing it in an HSM? I mean, you don't even put it in the disk. You take it from the HSM.
Yeah.
That gives you the persistence for the key.
Yeah. So
How does Git fit?
Unfortunately, nothing there, right? There's nothing. I mean, if you're using an HSM, you don't have to worry about committing source code or the credential or encryption or anything like that. So using Git is the right answer when you don't control the technology. Maybe your cloud provider doesn't provide a cloud HSM, or you have access to the data center where you can plug in one of these pieces of technology. It's probably a good reminder that if your cloud provider doesn't offer an HSM and you're working in a regulated space, that you may need to think about a different provider. That's really all I can say there.
Okay, and the second question connects with that is, imagine that you have maybe some providers give you this, bring your own keys, or in your own systems you do this, but you are accessing other services, might not be super important, but they do regular passwords and keys and things like that. Do you recommend to leverage the bring your own key, your generated key in production to encrypt those other secrets that you cannot protect otherwise, and then use that key to actually with the public key, and then use that key to decrypt them when you are going to consume them in production, or do you?
I'm not sure I totally fully understand. You have another, like 2 service providers. One of them doesn't offer bring your own keys. Is that what you're saying?
So how do you protect everything else if you already have this system? Can you leverage this system to protect more rudimentary passwords and keys?
I'm not sure I totally understand. I'm sorry. You can layer this system on top of other credentials. So you can actually use the key management service and the data key that you're using. I'll go back to this real fast. In this situation, this data key doesn't have to be unique per credential. So if you have a whole list of credentials, you can actually use this data key system to encrypt any credential you have, and they can encrypt all the same credentials, which means you can bring a first-class secrets manager into your production application without having to use another provider or have those credentials exposed anywhere else. There is a recommendation to use a different data key per credential, but due to performance limitations, having a layered approach can also work really well. Does that answer your question?
Yeah.
Awesome.
Thank you.
Okay, now
Awesome.
it's mine. So first, thank you very much for the talk. I have a question about sending the public key to your service provider.
Yeah.
So how do you authenticate that? Because we are talking about the production system versus service provider authentication, but also the service provider needs to know that that public key is connected to your identity.
Yeah.
And then we can go recursive, and then
Yeah, good call out. No, definitely. So I think there is a root of trust problem here. This is actually what a TPM solves. I don't want to get into that, but I will say that fundamentally you have to authenticate yourself some strategy before uploading a public key. So hopefully two-factor authentication or n-factor auth on the user, the engineer that goes and uploads the public key. That's the easy cop-out answer, I'm going to say, but it does solve the problem, right? Once you're in an authenticated context, you can upload any credential you want without there being a problem. There is an alternative strategy. There is an RFC out there for OAuth 2 that suggests dynamic client registration. So anyone in the entire world can just upload a public key to your service, and that creates a user. Well, that can also create the account and do everything, and that becomes the root of trust. So now, I've never seen a product that actually supports this, but fundamentally, there's no harm in doing that. I mean, obviously, you have to protect your upload public key endpoint because people will be spamming it with nonsensical implementations. But yeah, you have to be authenticated in some way or segregate that upload to its own account to be secure.
Okay, thank you very much.
I will say that I'm going to be here for the next 2 days. It's actually 2 days, unfortunately, fortunately. And for lunch, I'm actually going to sit outside because it's so nice today, and I'm from a colder place, so outside in front stairs. So if you have more questions, feel free to come and harass me. It's going to take me like 5 minutes or so to actually grab my lunchbox, but I will be out there. And I don't see any more questions.
So first of all, congratulations on your talk. And my question is more than a question. I wanted to see how you think about different topics on permissions. So I have seen some systems implement the security practices. I don't think all of them, but maybe the committing and storing secrets on Git. And I have seen a separate Git repository being used for all credentials of a maybe topic or kind of systems, maybe more protected and separate from the repository where the application code resides. And I'm curious about where your thoughts are on these. So where to store them? Maybe on a different repository, more protected, how to deal with staging, production, separated by branch or by credentials. Just to hear your thoughts on that. Thank you.
So what do we do with credentials in general? That's sort of what I got out of that. I mean, I feel like maybe you, while I was giving the presentation, you took a link at our company's website, and we're trying to ask some questions about that. But what I will say is that simpler is always better. I think look at the number of systems that you're including or the complexity number of repositories you have. I think there's a lot of arguments that go around, justified, unjustified, about, oh, let's have separate Git repositories or separate applications, separate Docker containers, separate pipelines, what have you. I think you have to remember that anything that starts with that is usually a mistake. It's not that every solution is wrong. It's just that when you make something more complex when it comes to security, it's less likely to be used, and it becomes more complicated to actually get right. So if you're not sure how to implement something and you're not sure where the security is, just going about it and trying to make it happen usually causes it to be less secure overall. So I can't speak to your specific use case, I'd have to see it in play. But as soon as you're like multiple repositories, I'm going to be like, microservices, one repository, one deployment, all credentials in there, CI/CD, everything, centrally located. Only the team that should have access to that. But maybe you're doing something interesting, in which case, who am I to say that that's not appropriate?
Thank you.
Okay.
Quick question. When you are the client side, when you don't have any access to the server side, you are not a provider of the keys. You have the basic, most authentication secure process possible. Do you think that regeneration of keys is something that should be taken into consideration, or do you trust, or do you think it's possible to trust the process that you have, that you generated the key once and you don't change it ever?
Yeah, let me see if I can just maybe twist the question a little bit to make it more generic. Do you trust the engineers at your company to generate credentials for your third-party service providers and to store them? And when they leave the company, how do you deal with rotation or prevent those credentials from being exfiltrated? I mean, I'm a big fan of saying, leading a company that does some sort of security in the permissions and authentication authorization space, that you have to trust your engineers. There is someone you're going to have to trust with the business or that service, and to have the smallest blast radius as possible. You can design your own systems against your own negligence. I make tons of mistakes when I write code, which doesn't happen super frequently. That I write code. I make mistakes all the time when I'm writing. So I think you do have to worry about that. Like, oops, I blew away production or the production credentials. If you don't have the credentials generated in a way which you're comfortable with the risk profile that your company has, and this is doing risk modeling now, right? This is the threat model we have. This is the potential attackers we think we're going to have. If you're not comfortable with that, I absolutely would rotate all of your credentials, immediately. Detection engineering is a very, very challenging subject. How do we know we haven't been breached? And the truth is, all we know is, with any sort of confidence, is we haven't been breached yet. Because there could be undiscovered 0 days, and just when quantum computing is around the corner, elliptical curve algorithms may no longer be sufficient. And so anything we've encrypted and put publicly will get exposed at that time. But even without that, unless you're somehow monitoring the usage of your users and how they're accessing your systems, or you get a support ticket that says, hey, I didn't do that, you're never going to know that those credentials have actually been leaked.
So basically a good practice. Okay, thank you.
Good luck. I think this is going to have to be the last question.
Hey there. First, congrats on the talk. It was amazing. A lot
you.
of good information there. My question is just even with the last question, right? How often do you see people doing simulations of like a attack, or getting used to what to do if you have a big incident? And how often have you seen that in the past? Or if you know people doing that often, what's your point of view on that? Thank you.
How often have I seen simulation of attacks? There is a shared strategy in the security space known as red and blue teaming, where you do segregate some internal engineers to perform the specific action of trying to compromise your production systems. There's also companies dedicated to doing this. I've never seen a company actually implement this. So while they exist and some companies may be paying for it, I can guarantee you that maybe some of the bigger ones, brand names that you may have heard that run giant platforms, are probably doing something internally or hiring security audit vendors, but most companies aren't doing that. There's a lot of things that come before it. Like, jumping in and doing that is sort of a Pareto principle long tail exception, right? If you're put in even 20% of the work, you can get 80% of the security. We're talking about red and blue teaming and finding potential vulnerabilities in your stack is all the way far tail. So while you There are things that you can probably be doing that are going to offer a lot more value.